Okay, so what we are going to study is dependency parsing, and the following topics will be covered over here. So we are going to know about phrase structure grammar, not about dependency one, and we'll see how to parse a sentence into different phrases. Now let's have a look at this example. So uh, in this example, we have few words like cat, cuddly, buy, door, the, etc. and so on. We have sentences. Now, if we this is the cuddly cat is itself a phrase, so it is having somewhat uh, some meaning, and it is representing something. So this is a phrase, the cuddly cat by the door, because by these words are dependent on door itself, because we are talking about door. Okay, so this whole set of words is creating making a phrase. Similarly, the cuddly cat by the door, this is the even bigger phrase. So today we are going to see how all the structures in the sentence and how these structures are useful. For example, in English language or any other language, we always have a structure defined, like these and these words generally come together. Noun occurs after this, adjective occurs before a verb, and so on. So we need to identify the structure behind the sentence. Okay. So before moving on, so first of all, we have to capture the constituency, basically ordering, or the rules that govern the ordering of the words, how these words are occurring, basically sequence, and those sequence we are going to create a grammar for that. For example, if we have a sentence, so if I'm saying a black door, so door is a noun, and I'm talking about door, so door is of black color, so black is the adjective, right? So I'm talking about that door. So generally, in general scenarios, what happens is whenever there's a noun, adjective will come before the noun. Okay, so basically this is ordering or structure of the sentence. So similarly, constituency is about how these words group into units. So we'll talk about phrases, not the individual words. We'll talk about a set of phrases and how these word units behave, how these set of words behave. Okay. So today we are going to see role of these phrases. Okay. Let's see. So, first of all, let's understand what is a noun phrase. So, if I'm talking about three parties from Brooklyn, so we are talking about Brooklyn. So, everything that is dependent upon Brooklyn will constitute noun phrase. Like Harry the house, Harry the horse. So, horse is noun, and we are talking about its name. Okay, and so on. So this is noun phrase. Similarly, so in a simple sentence, if you have any noun or anything that is surrounded by set of words, and those words which are dependent on that particular noun. If I'm talking about White House, and I'm talking about its color, so if I'm talking about table, if I'm talking about pen, uh, anything. So if I'm talking about any noun, and the words associated with that noun constitute the noun phrase. Similarly, how do we know that these words form constituent? Constituent is just those set of words which constitutes a phrase. Now, how do we know that these form a constituent? So first of all, they all they all can appear before a verb. For example, uh, three parties from Brooklyn arrive, this is verb, and the whole noun phrase appears before the verb. Okay, so but individual words cannot always appear before the words. For example, from arrive, but three parties from Brooklyn, this whole constitute a noun phrase, but this from does not constitute a noun phrase. Okay, so in general scenario, if we have a verb, so anything that is before the verb is a noun phrase. Okay, and must be able to state generalizations like a noun phrase occurs before verbs. Okay, so this is called a constituency, like a set of words appearing together. Then preposing and postposing. For example, this is fine on September 17th. This is fine, but on and September 17th separately is not fine. Okay, this does not means a constituency. Okay. Now, before discussing this, let's see an example. We'll suppose we have a sentence like, suppose we have a set of words like the cat the cat, then we have a dog. Okay, then we have maybe a large so this is a set of phrase. This is a phrase in a crate, on the table, by the door, a dog, the cat. Okay, all of these are phrases. Now let's see what do these represents. So first of all, let's see. So this is a determiner or article, right? This is noun. Now, using these two, what we can say about the grammar? So, can we say like whenever there is a noun phrase, so from a noun phrase, a determiner is generated and a noun is generated, right? So that is a determiner and a noun. Okay. Now, what if the cat was of black color? So the black cat. So black is adjective. So the large cat, the barking dog. So barking is adjective. So along with determiner and noun, there can be adjective associated with this, right? Determiner. Then we can have optionally adjective and noun. So the black cat, the brown dog, right? So this is how can we represent this whole scenario like this? Yes, we can. We have a determiner, then we have optionally an adjective, and then we have a noun, right? Then after this we have let's say we have the cat was sitting on the table. So the large cat on the table. So this is a preposition phase. Okay, so we can say there's from a noun phrase we can generate these three along with a preposition. So determiner, adjective, then a noun, and then preposition. So this is a preposition phase on the table, where on is preposition. The table is again. Now you can see the recurrence over here. The table, the cat, a dog. This is again a noun phrase, right? So from so this whole was preposition phase. This whole was your preposition phase, right? On the table. Now from this preposition phase, what two things are appearing? First is preposition, that is on, and second is again the table is again noun phrase, right? Similarly, after that, so you can see this is a recurrence again from noun phase. It can generate a longer sequence. It will come over here and it will say, okay, the table, the large table, the green table, the red table over here, and then the red table with something. So even a larger sentence. For example, the sentence can be the cat or we can say a barking dog by the large crate on the table. So this is a even larger sentence, right? Now a barking dog, if you see, this is a determiner. This is whole, we are talking about dog. So this is noun phrase. Again, by the this whole is a preposition phrase, which is further divided into subsets, preposition, and a noun phrase. And then this whole noun phrase is further divided into the large crate. This is again a noun phrase, and on the table is again a preposition phrase. Preposition phrase. Now this is again further subdivided into preposition and a noun phrase. The table, right? So this is how even longer sentences are generating. So this is what this is what meaning of this is. Like if you are having a sentence, that sentence can be divided into structures. Each and every sentence that is in a language, maybe in English, uh, follow some structure, and that structure can be defined by its grammar. Okay, so if in your data set, if you have 10 sentences, those 10 sentences should and must follow the grammar defined by you. Okay, so this is how we need to parse the whole sentence into a different set of phrases. Now let's see how to create a tree for this one. Suppose similarly, so initially we had a the whole sentence was the large cat. So the whole sentence was, let's say, root was maybe sentence. So the was a determiner, and large cat was adjective optionally, and then noun, right? Similarly, if you are not going with this, you can further divide this into subsets. Was optional, then we have a noun, and then if you can look back over here, noun, then you have a preposition, determiner, adjective, noun, and preposition, right? So we can see we have a preposition phase. Now preposition phase was further divided into preposition and on the table. So the table was again a noun phrase, and this noun phrase was further again divided into uh, determiner, maybe optionally adjective, and then optionally noun, and then optionally preposition phase, right? And then preposition phase was further divided into, and so on. So you can say a large cat on the maybe table by the door. Again, a determiner and a noun. So by the door. So clear. So each and every sentence is basically uh, you are dividing it into, passing it into in the form of a set of phrases, and each and every phrase is you are just representing it in the form of tree. So this is what we are going to study today. Like each and every sentence can be passed into set of into subsets, basically phrases, and that structure should be followed throughout your whole corpus. Okay, now let's this is clear. Parsing of a sentence into phrases and subsets. Okay, so I guess no questions about this. Now we have seen the example of a noun phrase only. This whole was the noun phrase. Now in a sentence you also have a verb phrase. Like a large cat was doing something. So any doing something was walking on the street. Walking is a verb. So walking on the street is a verb phrase. So this whole is a noun phrase, that because we are talking about the cat. itself. So up till here, noun phrase ended. After this, that large cat was maybe doing something, so that work will represent the verb phrase after this. So each and every similarly, each and every sentence is divided into noun phrase and a verb phrase. Verb phrase will determine like walking on the street, eating something, doing something, and so on. Okay, so up till here, noun phrase can be broken down recursively as long your sentence is, depending upon the length of your sentence. Similarly, verb phrase, it can do multiple things, and recursively that can again broken down into a set of phrases, set of uh, basically maybe preposition, noun, and so on. Okay, then noun phrase is divided into determiner and nominal, which is noun, and verb phrase is uh, uh, can generate a verb, and that verb can be, so they are giving example like if flight left. So left is departed, so a flight and then left. So verb phrase is generating a verb. So for this sentence, this whole grammar is sufficient. Okay, now if you have a longer sentence, so you need a foolproof grammar where all the sentence in your corpus are represented by that grammar itself. Okay, so context-free CFG is a context-free grammar. Now, any grammar where you have a non-terminal node in the left side and terminal nodes on the right, or anything on the right side, that is called a context-free grammar. And we are going to represent all the sentence using context-free grammar itself. Okay. So we have discussed this, like from each and every sentence, a noun phrase and a verb phrase is generated. Now, one thing is, uh, whenever you are creating a tree like this for representing your grammar or for a particular sentence, all the suppose you are representing a context-free grammar with a tree. So all the sentences, some sentence, it should not accept those strings. That tree should be made in such a way that it should not accept those sentences which are not accepted by your grammar. For example, the large cat is fine, but the cat large is not fine. So you should make a tree that should not accept the wrong sentences. Okay. So this is how we define the structure of our sentence, whether it's correct or not. So context-free grammars are used basically to define the structure of your sentence. Similarly, now how to derive this? We have seen like we create a grammar for our sentence, and it should cover all the elements. So whenever you are you are creating a tree for your sentence, it should cover all the element that or the words that are present in your sentence. No word should be missed out, and it should cover only whatever is given in your sentence. It should not cover some other words that are not relevant while deriving that tree. So this is the example. So noun phrase, verb phrase. Noun phrase is I prefer, verb phrase, then a noun phrase is further divided into determiner, noun, and a noun, morning flight. Okay.
मैम आज क्विज है क्या?
क्विज है?
मैं पूछ रहा हूँ लाइक आप है क्या? ओके मैम.
ओके, सो यहाँ तक किसी को कोई डाउट किसी चीज में? कंटेक्स्ट फ्री पार्सिंग.
नो मैम.
ओके, ठीक है. अब इसके बाद जस्ट रिप्रेजेंटेशन, हम क्या क्या चीज़ें होती हैं कंटेक्स्ट फ्री ग्रामर में? 4 चीज़ें होती हैं. इफ़ यू हैव ऑलरेडी स्टडीड दिस, नॉन टर्मिनल सिंबल्स, टर्मिनल सिंबल्स. टर्मिनल सिंबल्स ये होते हैं आई प्रेफर अ मॉर्निंग फ्लाइट, दिस इज टर्मिनल. नॉन टर्मिनल इज जिससे आपका कुछ और भी जनरेट हो रहा हो. फॉर एग्जाम्पल वर्ब फ्रेज, इससे आपके वर्ब, नाउन फ्रेज, अदर थिंग्स आर गेटिंग जनरेटेड, तो ये टर्मिनल है. जो लीफ वाले रहेंगे वो नॉन टर्मिनल रहेंगे, बाकी सॉरी लीफ वाले जो रहेंगे वो टर्मिनल नोड्स रहेंगे, बाकी सारे नॉन टर्मिनल रहेंगे. देन प्रोडक्शंस, तो जिस तरह से हमने यहाँ पे दीज आर कॉल्ड प्रोडक्शंस, तो जितने भी लेफ्ट साइड वाले रहेंगे वो नॉन टर्मिनल नोड्स रहेंगे उनसे, क्योंकि आपका कुछ जनरेट हो रहा है, ठीक है. और जो लास्ट वाले रहेंगे लाइक नाउन वर्ब, दिस इज टर्मिनल. देन वी हैव प्रोडक्शंस एंड अ स्टार्ट सिंबल. तो स्टार्ट सिंबल रहेगा आपके कंटेक्स्ट फ्री ग्रामर में, ये 4 चीजें होती हैं. ओके, देन पार्सिंग. तो पार्सिंग इज द प्रोसेस ऑफ टेकिंग अ स्ट्रिंग and a string, basically a sentence, and a grammar that you have defined, and returning parse tree for that string. Now you can return, question is you can return one parse tree for one string, or you can return one or more parse tree for a same string. So answer for this is you can have multiple parse trees for one string, but that is called ambiguous grammar. For example, if you are having a sentence, for that sentence, if two parse trees are getting generated using the same grammar rules, so that grammar is called ambiguous grammar, because we don't want our machine to, whenever it is parsing, we don't want it to generate two types of trees in the uh, uh, in parsing process itself. Okay, so it should create only one parse tree corresponding to each and every string, each and every sentence. Okay, now context. Now you can see the notion of context in CFG has nothing to do with the ordinary meaning of the word context in the language, because context, we are not considering context, we are just considering the uh, structure in the sentence. So means that I can rewrite A as B followed by C regardless of the context in which A is found. So context of A is not important. So that is why these are called context-free grammars. Now sentence, noun phrase, verb phrase, and prepositional phrase. 4 things are there whenever you are talking about any language, maybe English. So example, imperative, declarative. So this is just English. Question, types of sentences. Noun phrases, the president, or something like that, a morning flight. So types of noun phrases. Then you have preposition phrases, to the store, on the table, and so on. So whenever, okay. Now let's come to parsing. Now for parsing, you have many algorithms proposed already. So many parsers are available: top down, bottom up, shift reduce. So many parsers are there. Let's see. So we are not getting into details of those algorithms. We are just going to have a look at how this process is done. Okay. Let's see. So there are two types of grammars. First is dependency grammar and second is phrase structure grammar. So what I have discussed till now is phrase structure grammar, that is context free grammar. Okay, so phrase structure grammar we are going to have a look at, and we are not going to discuss about dependency grammar. And the syntactic parsing of a sentence is basically finding the syntactic structure of that sentence in the grammar. Okay, so dependency grammar and phrase structure grammar, out of these two we are going to talk about phrase structure grammar, which is our context free grammar. Okay, now let's see about phrase structure grammar. We have discussed this, breaking a sentence into constituents or phrases, then describing its phrase structure, clause structure, and so on. And it is recursive. We can generate recursively. We can generate phrases recursively, as we have seen in the example. Now let's see another example. So noun phrase, verb phrase. Now from verb phrase, noun phrase is again getting generated. So red figures on the screens indicated falling stocks. Okay, so this is phrase structure grammar. Uses context-free grammars. Next one is dependency grammar. So this is second type of grammar. I'm just introducing this one. but we are not going to use this one. So in dependency grammar, syntactic structures are linked by binary asymmetric relations called dependencies. You will find this dependency grammar, some people are using it. If you'll scroll through online videos or something, you will find people are using this one. Okay, so it does not propose a recursive structure while it creates a network of relations. So it does not talk about recursive structure. It talks about a network of relation. We'll see how. So this is a dependency tree. So here you can see like so figures. So there, first of all, there's no root node. Second thing, figures. So red figures. So what type of figures? So figure is red. So red is dependent upon figure. Okay. Then similarly indicated. So what, when, why, where, these kind of questions are there. Okay. So indicated what? Figures. So what indicated means, so something is happening. So that is defining what is happening. So what is happening is falling stocks, and where so many questions are there. So dependency of indicated is defined by falling stocks. So indicated about stocks, and stocks, what kind of stocks? That is falling stocks. Okay, so this is how, so this is a dependency tree. First of all, there's no you can see root node. Secondly, subnesting it there, but no recursion. Instead, what it defines is a network. Instead of dividing it into phrases, noun phrases, and so on, subsets, it shows the dependence of one over the other. Now, for example, figures. So what kind of figures? So figures on the screens. Figures where? So you always ask questions like where, what, when, how, where, and then you find out the dependency. So on the screen, so this is a subset. So on the screen, on, where, so on the screen, so on the screen should appear together. So the screen should appear, so the is dependent upon screen. So this is how dependency works. Okay, so you can see like there are two primary differences. We'll talk about it over here. So in dependency, there's uh, there are phrases and some substructural categories and some functional categories, but basically that is grammatical functions. While in dependency structures, there are directed args and labels, but one thing that is not there is root node is not there, and secondly, uh, subdivision into subcategories is not there. Only it defines where one word is dependent on the other. It defines a network kind of thing, while it does not tells you like it is something is recursively occurring. Okay, so these two things are there. So we are going to talk about phase structure only. We are going to talk about this dependency parsing only in this. So let's see. So this is the formal definition. We are just taking a input sequence and we are creating a tree. And after, whenever we have a generated tree for a particular grammar, we will, and whenever a new sentence one comes, we pass it. Sentence two come, we pass it according to that tree, that already generated grammar. So that is simple thing. Now in a dependency graph, you have a single head, it is acyclic, there is no cycle. Although recursion is there, then it is connected, all the nodes should be connected. And projective, if a word A depends on B, then all the words between A and B are also subordinate to B. For example, whenever you are talking about dependency tree, one thing you will notice is generally in English, you will notice it this, like dog is not dependent upon something that is appearing somewhere outside of that dependency. For example, you can see saw and yesterday. So everything that lies between saw and yesterday will interrelated in between itself. There's no, this red dependency generally is not there. This is called projective dependency. So this is generally not there. So whenever you have a dependency of between two words, so all the intermediate words will be dependent on each other, and it will not be the case like a dog is dependent on something that is outside of this uh, dependency, in which subordinate it is appearing subordinate to. Okay, so this is our dependency tree. Now uh, okay, so where it is useful. So multi-document summarization. So how do we do that? So to identify the sentences from different documents that each say roughly the same thing. For example, if we have a two sentence and two sentences appearing in two different documents, and because the grammar of these two documents would be different, so parsing, so whenever, because but the sentence was same, sentence one in document one and sentence two in document two, these two sentences were same, but because the grammar was different, so it will generate a different parse tree for each both of them. So this is basically useful in multi-document summarization to identify, separate out sentence. Okay, no, this sentence meant this thing and this sentence meant this thing. Okay, similarly, phrase structure trees of paraphrasing sentences which differ in word order can be significantly different. For example, uh, somewhere, basically whenever we are creating the phrase structure tree or parse tree of any sentence. So that can so it is useful in defining the meaning of the sentence in the way, for example, uh, let's say two words that are appearing together in a sequence a b, and second time it is appearing as b a. So if you create the parse structure of a b and if you create the parse structure of b a, you will find a different kind of tree. Although it may happen like these two can have same meaning, or it may happen like these two can have different meaning. So paraphrasing them, so creating a tree will give a better picture of what the sentence is trying to convey. Okay, so here dependency passes are useful. Now let's see uh, ambiguity, disambiguation. So we have already discussed this. So whenever we have a sentence and it is getting passed by two trees, or we are generating two or more trees for the same sentence, so or the same grammar, so that is ambiguous case, and we need to remove ambiguity and we need to perform disambiguation. And whenever we are generating a grammar for anything, any set of data, maybe a corpus or a document or anything, we need to disambiguate it. We need to check, like for each and every sentence there should be only one parse tree itself. Okay, now these are some of the available trees, tree banks available to you. You can explore this one. Now there are three algorithms basically to parse. So first is dynamic programming based, second is constraint satisfaction based, and third is deterministic search. So these three approaches are there in general scenarios, and there are many algorithms proposed in each of these. So just don't you don't need to have a look at them. Just you can just go through it, like but we are not going to study these algorithms in detail. Okay, so what are the advantages and disadvantages? So disadvantage of this is we are not considering the we are not considering the overall meaning of that sentence. We are just looking at the structure. And advantage of this is you are getting a better, because you are able to identify the underlying structure in the sentence, and you are able to identify the semantic relationships between the words. Okay, so uh, uh, that is it about dependency parsing. So that's it. Any questions, anything that is not clear? just have a basic idea about what it is. Suppose in exam, I'm asking you, you have been given a grammar, and you can be asked for maybe uh, uh, some sentences are given to you whether this is a correct grammar or not. So prepare this kind of things, like you should know the how to generate a grammar for a sentence, and whether the grammar generated for a set of string is correct or not, or whether a string is belonging to that grammar or not. So these kind of things you need to study in this.